Good morning, good afternoon, good night, whenever you're watching this. Hope you're well. As you can very clearly see on the smartboard here, we are going to start our unit on light. And today is just going to be a short introduction, but this video will kind of lay down some basic facts for you. We're not going to dive too deep into it today, but we're going to start trying to look at light a little bit differently than I guess you do now. I think a better way to say it would be, I guess we're going to learn to appreciate it a little bit more. So we're definitely going to think about light a little bit differently than you probably have in the past. Just real quick before I start going into it, it wouldn't be a bad idea if you brought your science notebook home, or just if you have a notebook or notebook paper, to press pause and jot down some notes. Anything that you see on these slides, we're going to be writing down in class. So it wouldn't hurt for you to do the same at home. And that's why I like these videos so much, because you can go at your own pace. You can pause, you can rewind, whatever's best for you as an individual. So any information that you can take from this, put into your notebook, could be helpful for when you come back, or it could be helpful in future assignments that you do, so you don't have to come back, find these videos, and get this information back. So if you have that stuff handy, I think it would be a great idea to take some notes. If you're more comfortable just watching these videos and bookmarking them and coming back to them, that's cool with me as well. So just a couple of basic things when it comes to light. There are some things that you want to know, and I think the first thing's pretty obvious. It's a form of energy that we can see, and light allows us to see. And these light waves, they travel in straight lines, and the way that they travel, they're going to stay in those straight lines until they hit an object. And at times they'll bounce off, at times they'll go through, at times that light will absorb. And I'm getting a little bit ahead of myself, because we'll start talking about this a little bit today and moving forward this week. But it is important to know that those light waves travel in straight lines. The most important thing today, and this is really what we're probably going to spend most of our time talking about, is this third line right here. There's a ton of different sources of light. My computer screen is putting off light. My iPhone puts off light. Flashlights put off light. I'm going to kind of see if I can do this. We got light coming in through this window, even though it's closed. We've got light coming from the TVs. I've got a lamp. Let's see if I can weatherman this. A lamp right here. And I've got an overhead light here. The only thing is, not all sources of light are the same. We got it broken down into kind of like two categories, right? So we've got natural sources of light, and we've got artificial sources of light. And I tried to break it down as simple as I could with this definition. So here, when it says natural, it means it was not man-made, okay? It just occurs naturally on its own. And I put some examples over here for natural sources of light. The sun's an important one, guys, because it is our biggest source of light that is naturally occurring. We don't have to flip a switch. We don't have to put a battery in that. We don't have to plug it into the wall. It occurs naturally. The stars are another example. Look up in the sky at night, you can see the stars. Those occur naturally. And then you've got a firefly. You can chase those at night. During the summer, they light up on their own. They don't go home and sit on a charging station every night. That occurs naturally through a chemical reaction. And there's actually I should have looked this up before. There's a fish, I think it's called an anglerfish. You know what? Let's see if we can find it. I think there's a fish called an anglerfish that does the same type of deal. I'm hoping you can see my screen right now. I don't think you can. Oh yeah, that thing is gnarly. So let me share this with you real quick. Share screen. Got an anglerfish that lives deep, deep, deep in the ocean, and it has one of these naturally occurring sources of light popping out of its head. Now, I'm not an expert on an anglerfish, so I don't know a ton about it, but that's just interesting. So any source of light that is not man-made occurs on its own. That's natural. But then, this is where I talked about maybe you don't have an appreciation for the artificial sources of light that maybe you should. So an artificial source of light is man-made, or it needs some sort of energy source. It needs to use a battery, or it needs to use an electrical outlet. Um, Anything that was man-made that we kind of have control of is an artificial source of light. So the examples that I got, a lamp, you're plugging that into the wall, candles that we can light on our own, a flashlight uses batteries. Anything like that would be artificial. We are so lucky, and we take it for granted, the privilege that we have to have so many sources of artificial light, when some people in other countries maybe don't have that privilege. So when you think of artificial sources of light, it's just stuff that you have every day, but you don't realize how lucky we are to actually have that benefit. So just from the examples that I gave you up here in the man cave, this window, when I open the blinds, can let in a lot of light. That source of light is natural because obviously it's coming from the sun. Everything else that I said, the light coming from the TVs, my computer screen, the lamps, the overhead light, what else did I say? My phone, all of those are artificial because they're either plugged into a wall or they use some sort of power source. This video would be a lot different if I didn't have this window and I didn't have that natural light coming in, because I could turn all these TVs off, and if it's a certain hour of the day, you may not be able to see me. Now the screen is putting off some light, so you are able to see. But the one thing I really want you to take from this slide here, know the difference between that natural source of light and that artificial source of light. So I talked a little bit about light traveling in those straight lines, and then it bounces off objects sometimes, and not all the time, because like I said, it can do other things. But when we're talking about light waves traveling and bouncing off an object, we call that reflection. And that's not the first time you've heard that word, because I know you can look into certain objects like a mirror, and you can see that reflection staring back at you. You can look down at a puddle or something, and a shiny object. You can look at it and you can see your reflection. So really, reflection's important because, guys, that's why we're able to see. So if you're looking right here, it says we're able to see objects either because they give off their own light, or light is reflecting off of the object and into our eyes. So like the TV, that's putting off its own light, so we're able to see it. It's putting off artificial light. My computer screen, I'm able to see because it's putting off that artificial light. It's plugged into the wall. Our eyes, we don't produce light with our eyes, we're just able to detect it. So I think the best example that I could think of with, hey, how am I able to see this when light reflects? When you look up at the sky each night, you can see the moon. Very similar to the sun. A lot of people think, ooh, the sun puts off its own light, the moon puts off its own light. Guys, the moon does not produce any light at all. It has no source of light coming from it. The reason that we're able to see it is the light from the sun is shining towards the moon. Those light waves bounce off the moon, reflect off the moon into our eyes, which is why we're able to see any object at all. When I give you a sheet in class, a worksheet, worksheets don't put off light, but we're able to see them because the artificial light from the classroom lights bounce off the homework sheet, reflect into our eyes. So if you can't see something, let's say you're in a room and it's pitch black, that's because there's no light reflecting off of objects to see. So it's kind of like when you cut off the lights to go to your bed and you kind of have to feel because it's pitch black. You can't see your bed because there's no light reflecting off of that bed into your eyes. And this was a pretty good visual, I thought. Light traveling in a straight line, bouncing off your homework, right into your eyes. Same deal works with a mirror. Now, mirrors are super smooth, they're straight, they're not curved, nothing crazy. That's why when the light bounces off that mirror, reflects off that mirror into your eyes, you see yourself exactly how you look. So if it's bumping off a smooth surface like that, it's going to come back to you just the way it is. I don't know if you've seen these funhouse mirrors before. Like if you go to a carnival, it's totally different. You'll stand there and you might look like you're 2 feet tall. You might look like you're 600 pounds the way it contorts your body. So those funhouse mirrors, instead of having like a normal mirror like this, Sometimes they're pushed in or they're curved. That way, when the light hits, it does reflect, but it doesn't come back to you the same way that you see yourself. So if I am to ask you, hey, why are we able to see anything? It's because light is reflecting off of the object into our eyes. And for your exit ticket that you're going to do, this example right here is really important. You've got to know that the moon doesn't put off light. It only reflects. So this is just one example of what light can do. It does not always reflect. There's actually two more things that we're going to talk about. We're just going to stop right here for today. But tomorrow you'll kind of learn what else light can do if it doesn't always reflect off of an object. So just quick little recap. Two different sources of light. You got your natural sources, your artificial sources. Remember, your artificial sources, we are pretty much in control of them, whether it means plugging it in, turning it on, powering it up with batteries or some sort of power supply. Those natural sources of light, they just happen. We've got no control over it. They occur on their own. And then, last but not least, remember, reflection gives us the ability to see anything. Light rays travel straight lines, reflect off of an object, shoots into our eyes. That's why we are able to see. So I tried to make that kind of...
My apologies. I couldn't hear what you said.
That's because I wasn't talking to you. And another source of artificial light. Boom. How about that? Thank you, Siri. I apologize. I tried to make that as easy to understand as I could while still being informative. So since you've watched this video, you can go back to the announcement. You can complete that exit ticket. I think it's 4 questions. And then tomorrow when you come back, we'll learn a little bit more about what those light rays are capable, or light waves, excuse me, are capable of doing. Thank you guys for watching. You're the best. Goodbye.